After 10 months flying in space, NASA's Double Asteroid Redirection Test, DART, the world's first planetary defense technology demonstration, successfully impacted its asteroid target on Monday, the agency's first attempt to move an asteroid in space. Mission Control at the Johns Hopkins Applied Physics Laboratory, APL, in Laurel, Maryland, announced the successful impact at 7:14 p.m. Eastern Time. As a part of NASA's overall planetary defense strategy, DART's impact with the asteroid Dimorphos demonstrates a viable mitigation technique for protecting the planet from an Earth-bound asteroid or comet, if one were discovered. At its core, DART represents an unprecedented success for planetary defense, but it is also a mission of unity with a real benefit for all humanity, said NASA Administrator Bill Nelson. As NASA studies the cosmos and our home planet, we're also working to protect that home, and this international collaboration turned science fiction into science fact, demonstrating one way to protect Earth. This first-of-its-kind mission required incredible preparation and precision, and the team exceeded expectations on all counts, said APL Director Ralph Semmel. Beyond the truly exciting success of the technology demonstration, capabilities based on DART could one day be used to change the course of an asteroid to protect our planet and preserve life on Earth as we know it. DART targeted the asteroid moonlet Dimorphos, a small body just 530 feet in diameter. It orbits a larger, 2,560-foot asteroid called Didymos. The mission's one-way trip confirmed NASA can successfully navigate a spacecraft to intentionally collide with an asteroid to deflect it, a technique known as kinetic impact. The investigation team will now observe Dimorphos using ground-based telescopes to confirm that DART's impact altered the asteroid's orbit around Didymos. Researchers expect the impact to shorten Dimorphos' orbit by about 1%, or roughly 10 minutes. Precisely measuring how much the asteroid was deflected is one of the primary purposes of the full-scale test. The spacecraft's sole instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, DRACO, together with a sophisticated guidance, navigation and control system that works in tandem with small-body maneuvering autonomous real-time navigation, SmartNav, algorithms, enabled DART to identify and distinguish between the two asteroids, targeting the smaller body. These systems guided the 1,260-pound box-shaped spacecraft through the final 56,000 miles of space into Dimorphos, intentionally crashing into it at roughly 14,000 miles per hour to slightly slow the asteroid's orbital speed. DRACO's final images, obtained by the spacecraft seconds before impact, revealed the surface of Dimorphos in close-up detail. "What a remarkable day for humanity," said APL Space Exploration Sector Head Bobby Braun. "The team nailed it, and I couldn't be more proud of their efforts. Data from this test will inform future planetary defense efforts." Today is a milestone in demonstrating just how far our nation's space program has come, and how important it is to all of us here on Earth. 15 days before impact, DART's CubeSat companion light Italian CubeSat for imaging of asteroids, provided by the Italian Space Agency, deployed from the spacecraft to capture images of DART's impact and of the asteroid's resulting cloud of ejected matter. In tandem with the images returned by DRACO, LICIACube's images are intended to provide a view of the collision's effects to help researchers better characterize the effectiveness of kinetic impact in deflecting an asteroid. DART's success provides a significant addition to the essential toolbox we must have to protect Earth from a devastating impact by an asteroid, said Lindley Johnson, NASA's planetary defense officer. "This demonstrates we are no longer powerless to prevent this type of natural disaster." Coupled with enhanced capabilities to accelerate finding the remaining hazardous asteroid population by our next planetary defense mission, the NEO Surveyor, a DART successor could provide what we need to save the day. With the asteroid pair within 7 million miles of Earth, a global team is using dozens of telescopes stationed around the world and in space to observe the asteroid system. Over the coming weeks, they will characterize the ejecta produced and precisely measure Dimorphos' orbital change to determine how effectively DART deflected the asteroid. The results will help validate and improve scientific computer models critical to predicting the effectiveness of this technique as a reliable method for asteroid deflection. Roughly 4 years from now, the European Space Agency's Hera project will conduct detailed surveys of both Dimorphos and Didymos, with a particular focus on the crater left by DART's collision and a precise measurement of Dimorpho's mass.